Hi, I'm Vivian, a software engineer on the core UEFI team, and I'll be talking about writing Google tests for UEFI. This is a part 2 video, so please watch the part 1 if you're just getting started. First, I'll give a brief introduction, show how to make a mock, then how to consume one, and I'll go over how to use a few useful Google test features. So before I get into how to create and use mocks, I want to go over why we use them. So mocks are used to create isolation of our unit tests. They let us test the interaction between the code we're testing and the external code it uses. We're not testing, for example, if our other drivers or protocols are behaving how we expect them to. We only want to ensure that the unit we're working on, in this example we'll be looking at a library, behaves how we expect it to, including upon interactions with external objects. Another huge benefit is the reusability of mocks across unit tests of all code that consumes a given object. So once we've mocked a library, for instance, we can use that in any test. We're going to make a new mock for PEI services lib, which lives in MDE package. The structure will look like this. Under our package, test, mock, include, Google test library, we'll make our header file, which should be the same name as our library with mock prepended. Then we'll create our mock library folder under our package, test, mock, library, Google test, also the same name as our library with mock prepended. Inside this folder, we'll create our source C++ file and INF. So first we'll make the header file. We'll need to include the Google test lib, the function mock lib, and the libraries we'll be mocking. It's important to notice the function mock lib we're including. It's a header file in our unit test framework package that creates a few macros for mocking functions and interfaces, so you won't find them in the Gmocks documentation. For example, here we're using two of those macros, mock interface declaration, which is used to declare our mock of the library itself, and mock function declaration, a macro for declaring a mock function for an external function, so a function that doesn't exist in the compilation unit. We'll just declare the one function we need for now, and we can always add more later. Now we'll create our source file and use a few more macros, like mock interface definition, which defines our interface with a constructor and destructor. Mock function definition defines our function to call our mock, giving it the number of arguments and the call type. Next, we'll make the INF with a new file GUID and include our relevant source file and packages. With our build options, we have this option appending EHSC to any existing build flags. The EH stands for error handling, and this flag enables C++ stack unwinding, so we can catch standard C++ exceptions. This also says the compiler assumes functions declared as extern C never throw a C++ exception. Finally, we can add our new mock INF to the package host test DSC under components. If there isn't an existing host test DSC for the package you create the mock in, you can create a new one. Okay, now we're going to use a mock. For this example, we'll actually be consuming runtime services table libs mock, as it may be more applicable and it also exists in our MDE package, and we're going to use it in our config nopshim dixie lib Google test. First, we'll add the relevant package deck inside the Google test INF file. Next, in whatever package we are consuming the mock in this case our Google test is in the setup data package host test, we'll go to the package's host test DSC and override the library class with our mocks INF. Now inside our Google test source C++ file, we can include any existing Google mock header files with Google test /library /our mock library. Now I'll create the mock instance. And in this unit test, I know that I'm going to be creating multiple test cases that will use the runtime services table mock, as well as some other variables like the EFI status. So I decided to create a test class to hold all of these variables so that I can reuse them across different tests. and this is a continuation of our class definition. I'm overriding the setup function so that not only can I initialize my variables, but with each test, my variables are reset to their original values. So now I've created a test using test_f. F stands for fixture, which is allowing us to use a test class, and you can see the first argument is our class name. Now, before we call a function we're unit testing, we know that function will make a call to runtime services table lib, so we use an expect call. In our expect call here, we are passing in our mock instance and specifying which mock function we expect to be called. In this case, it'll be grt get variable. We can see in the mock files we're consuming these mock function declarations and definitions, and we're going to use that knowledge to populate what we want this test to do with this mock call. There are many, many ways to tailor the expect call function to do what you need, so I highly suggest skimming through the Google Gmocks documentation and keeping it as a reference. In this example, we're going to use the will once method to say that the first call to this mock function is going to set the value of the fourth index 3 argument, which is data size, to be the size of variable data, one of the variables initialized by the class. We're then going to return EFI buffer too small, which is the expected first return status. Our second use of the will once method says the second call to this mock function will return EFI not found because this is a failure test. Finally, we'll test the actual function and use some assertions on our return status and variables. Now, aside from assert equals, there are plenty of documented assertions, including ones that use matchers like starts with or regular expressions even. Furthermore, assert macros generate fatal failures that abort the current function, while any macros that use expect instead of assert generate non-fatal failures that let the current function continue running. Now using the VS Code extension, or we can run the test regularly, we can verify everything succeeds and fails as expected. Another quick example here and good practice, we're specifying what we want the call to look like. Now in this case, all it's saying is our last argument should not be null. But we can use more matchers to check the value or even type check. Our will once here is similar to our previous one, but I wanted to show we can also set an argument buffer. This mocking reference from the Google Test docs is very valuable to use and understand the full capabilities of mocks and expect calls. I also recommend checking our README in MuBase Core for some Google Test samples and template. Thanks so much. If you have any questions, please feel free to send me an email or just send the team an email. Thanks.